On a planet where the gravitational constant is negative 14 feet per second, a ball is thrown vertically upwards from the top of a 320-foot cliff with initial velocity of 128 feet per second. Find its maximum height in feet. Show all equations. So we'll begin with the fact that the acceleration is constant, negative 14. I will highlight that this is a function of t, even though there are no t's on the right-hand side. Let's integrate both sides of this equation with respect to time. The integral of acceleration is velocity. The integral of negative 14 dt is negative 14t plus some constant. We know that the initial velocity is 128. So on the one hand, v of 0 is 128. On the other hand, we can just plug 0 in on the right-hand side here. And 14 times 0 is 0, so the right-hand side is c. So that means that c is 128. Next thing to do is integrate both sides of this thing again with respect to t. Need parentheses here because the integrand is more than one term. So up here, the integral of velocity is position or height. We'll call that s of t. Integrating negative 14t gives me negative 14t squared over 2, which I will immediately reduce to negative 7t squared. 128 becomes plus 128t. Don't forget your plus c. And we know that the initial height of this ball is 320 feet because it starts at the top of that cliff. So on the one hand, s of 0 is 320 even, and on the other hand, we can plug 0 for all these t's. And the right-hand side is simply c, so that means that c is 320. So then s of t is really negative 7t squared plus 128t plus 320. And now we want to know something about this ball when it's at its maximum height. So if you think about the ball when it's at its maximum height, we know for sure its velocity is 0. Just for that one moment in time, that ball is paused up there at its max. So we're going to set the velocity equal to 0. So let's solve this thing for t. So add 14t to both sides, and then divide by 14. We can reduce that and leave it as a fraction, but I think ultimately we're just going to use a decimal anyway. So I'm going to type this thing in right here. About 9.14 seconds. So that's how long it takes for the ball to get to its maximum height. And if I want the maximum height itself, we're going to plug that into the purple s of t function at the top right. So s of 128 over 14 is negative 7 times 128 over 14 squared plus 128 times 128 over 14 plus 320. And because I've already got that fraction typed in, I don't want to retype it a bunch of times. So I'm just going to store that as x. And then I'll simply type in negative 7 times x squared plus 128x plus 320. And we get right around 905. And that's the maximum height of the ball.